Alrighty, everybody. Now we're gonna continue our talk about vectors, but now instead of just geometry, we're gonna look at an algebraic approach. We're gonna start looking at this with numbers, adding and subtracting with those values, multiplying, all of that good stuff. But the first thing we're just gonna start talking about is how do we write a vector and doing some adding and all that good stuff. So remember, a vector has an initial point and an end point. Well, if we put that initial point and the end point on a graph, we usually like to put the initial point at 0, 0, because that's where we always start. And so where we end up, my terminal point of my vector will be a point AB. That means I can call this, instead of saying, hey, it ends at point, it has an end point of AB, I can write it as vector AB. Notice this isn't a typo. This is important. Parentheses mean points. These arrow-looking brackets let us know that AB is a vector with the endpoint of that vector at AB and the initial point at 0, 0. So we could say vector U, another way of calling this vector U is calling it vector AB. Okay, so we're letting us know that vector U is the vector that ends at that point. So in general, what this means is every vector in the real plane corresponds to an ordered pair. That makes a lot of sense. So geometrically, a vector is a directed line segment. It has length and direction. Algebraically, when I write it as an ordered pair, it still has length and direction. Go to the right 3, go up 2. That's my direction and my length. Well, we're not told the length directly, but we can figure it out. That's what we're going to be doing here in a minute or two. So the numbers A and B, like I just said, are the horizontal and vertical movement for that vector. Alrighty? So whether it's geometrical or as an ordered pair, we have magnitude, which is our length, and we have direction. So let's find the magnitude and the length for this vector U. They are writing it in our form AB. So as a nice visual representation, because honestly, who doesn't like nice visual representations? Let's put it on our grid. Here's our Cartesian grid, our Cartesian coordinates. And we want to do the vector 3, negative 2. So we're going to go right 3, and then we're going to go down 2. There's my vector. This is the vector we are talking about. And it has an endpoint of 3, negative 2. Well, how are we going to find the magnitude? Well, I'm glad you asked. Because remember, anytime we make a grid from a point, we can say, hey, let's go to the right 3, and then let's go down 2. And hopefully you're noticing this makes a right triangle. Boom, there's my right angle, where we're allowed to find the hypotenuse. C squared equals A squared plus B squared, where C is the magnitude, A is 3, and B is negative 2. Please notice I use parentheses because I want to square that negative. If I don't use parentheses, it won't square the negative. So that's going to give me U squared equals 9 plus 4. U squared equals 13. That means this vector has a magnitude of the square root of 13. There's its magnitude. So now they asked for direction. Direction is how many degrees my bearing, basically, or how many degrees, not the bearing. Bearing comes from true north. But bearing, how many degrees from the horizontal, the positive x-axis are we? Well, we've got x and y. So if we've got x and y, we can always find an angle measurement by saying the tangent of theta equals y over x. And I'm using y and x instead of maybe not like sine or cosine because I figured out the radical 13. What if I made a mistake? I can at least find the angle. So I know the tangent of its angle equals negative 2 over 3. So theta is going to be the inverse tangent of negative 2/3. So we find that theta is about negative 33.69 degrees. Okay, that's perfect so far. But please don't, we're not stopping right there. Because what that negative 33.69 is referring to, it's referring to this. But keep in mind, that's not how we always measure angles. Normally we measure angles, the degree in the angles like that. So to find our direction, how many degrees until we get to the vector, we're going to do 360 degrees minus 33.69 degrees. I'm going to back it off from the 360, and we find out our direction is going to be 326.31 degrees. Boom. So if we tighten our formulas up a little bit, let's tighten them up just a smidge. If I give you a vector in component form, AB, then the magnitude doesn't care about direction. That's why we always say in absolute value of this magnitude, the length of this vector can always be found just by doing the square root of a squared plus b squared. Don't have to do the whole Pythagorean theorem. And then my angle can always be found by taking the inverse tangent of y over x. So two important things to know. We're going to always hit those up, make it easy peasy. Sweet. Alrighty, so let's go ahead and if you have any questions, please make a note of them. So when we get to class, you can ask them and I can answer them, and we will all have a good time. So Gauchos, I will see you when I see you, and I hope you have a good one.